China just 3D printed a dam. Not a model, not a prototype. An actual, fully operational 180-meter tall hydroelectric dam, and they did it almost entirely without human workers on site. The Yangqu Dam on the Yellow River is the world's first large-scale dam built using autonomous 3D printing technology. The engineering behind it is so advanced, so unprecedented, that it is making civil engineers around the world stop and stare. Today I am breaking down exactly how they did it, why it matters, and what it signals about the future of mega infrastructure. What is the Yangqu Dam? Let's start with the basics. The Yangqu Dam is a hydroelectric dam located on the Yellow River in Qinghai Province, in the remote highlands of northwestern China. It sits at an altitude of roughly 2,600 meters above sea level. That is higher than most ski resorts in the Alps. The dam is a roller-compacted concrete gravity dam. Instead of the classic arch shape you might picture, it is a massive wedge of concrete that uses its own weight to hold back the water. Think of it like a concrete mountain. The scale is enormous. The Yangqu Dam stands about 180 meters tall. That is roughly 60 stories high. It spans over 1,000 meters wide. When fully operational, it will generate approximately 5 billion kilowatt-hours of electricity every year. That is enough to power millions of Chinese homes. But the story is not really about the dam itself. It is about how it was built. The 3D printing system. Traditional dam construction is brutal work. You need thousands of workers, enormous fleets of trucks and equipment, and years of carefully coordinating concrete pours, all in precise layers to avoid cracking or structural failure. At Yangqu, Chinese engineers from Tsinghua University and the state-owned construction company Power China took a completely different approach. They developed an autonomous 3D printing system. Essentially a swarm of intelligent machines that work together to build the dam layer by layer, just like a desktop 3D printer builds objects layer by layer. But instead of plastic filament, these machines use roller-compacted concrete. Here is how the system works. First, a network of sensors and cameras maps the construction site in real time. Artificial intelligence software processes this data and generates precise construction instructions for each layer of the dam. Then fleets of autonomous vehicles move into position. Unmanned excavators, autonomous cement mixers, robotic compaction rollers. They follow GPS-guided routes with no human drivers in the cab. Concrete is mixed and poured in exact quantities. Autonomous rollers compact each layer to the precise density specified by the AI. The system monitors itself continuously. If a section is not compacted correctly, the machines automatically go back and fix it before the next layer begins. And this entire process repeats, layer by layer, meter by meter, until a 180-meter dam rises out of the high plateau. The whole operation was reportedly controlled by fewer than a dozen human operators monitoring screens from a remote control room. No one had to stand in dangerous concrete zones. No one had to operate heavy machinery in freezing high-altitude conditions. Why this is technically remarkable. You might be thinking machines in construction are not new. We have had autonomous equipment before. What makes Yangqu different? 3 things. First, scale. Previous autonomous construction projects have been small. Individual buildings, road sections, simple structures. Yangqu is a 180-meter dam. The sheer scale of coordinating dozens of autonomous machines across a massive moving construction site, managing thousands of tons of concrete with millimeter-level precision, that is genuinely new territory. Second, real-time adaptive control. The AI system at Yangqu does not just follow a fixed script. It monitors actual conditions on site, temperature, concrete density, moisture levels, equipment position, and adjusts instructions on the fly. If the concrete mix is slightly off due to weather, the system compensates automatically. If a machine breaks down, others reroute around it. It is a living, responsive construction intelligence. Third, quality control at every single layer. In traditional dam construction, quality control is done by human inspectors at intervals. At Yangqu, every layer is verified by sensors before the next layer begins. Engineers claim the Yangqu Dam's concrete consistency actually exceeds what is achievable with manual construction methods. This is not just faster construction, it is potentially better construction. The Yellow River context. To understand why China built this dam here, you need to understand the Yellow River. The Yellow River, or Huanghe as it is known in Chinese, is China's second longest river and one of the most historically significant waterways in the world. It is called the cradle of Chinese civilization. It is also, historically, one of the most destructive rivers on Earth. The Yellow River has flooded catastrophically hundreds of times over thousands of years. It has changed course dramatically multiple times in recorded history. Managing the Yellow River has been a central challenge of Chinese governance for millennia. Today, China is in the middle of massive hydroelectric development on the upper Yellow River, the Qinghai section, where the river drops steeply from the Tibetan Plateau. Yangqu is one of several dams in this cascade, part of a broader strategy to generate clean energy, regulate water flow, and reduce downstream flood risk. The 5 billion kilowatt-hours Yangqu will generate per year is a significant piece of China's push to reach carbon neutrality by 2060. Hydroelectric power does not produce greenhouse gases directly, and the upper Yellow River has enormous untapped potential. But building in these remote, high-altitude locations is brutally difficult for human workers. Cold temperatures, thin air, rugged terrain. Which is exactly why autonomous construction technology becomes so compelling here. What this means for global infrastructure. Let's zoom out. The construction industry is one of the least automated sectors in the global economy. It accounts for roughly 13% of global GDP, but has seen almost no productivity growth over the last several decades. While manufacturing, logistics, and agriculture have been transformed by automation, construction has largely still relied on manual labor and traditional methods. Yangqu could be a turning point. If China has genuinely cracked autonomous megascale construction, and the evidence suggests they have, the implications are enormous. Think about infrastructure in difficult environments. Remote locations, extreme altitudes, Arctic conditions, disaster zones, places where it is dangerous or impractical to send human workers at scale. Autonomous construction systems could build bridges, dams, roads, and buildings in places that were previously inaccessible. Think about speed. The Yangqu project was reportedly completed faster than equivalent manually built dams. Speed matters enormously in infrastructure. Every month of delay is millions of dollars of lost productivity, lost energy generation, lost economic activity. Think about cost. Labor is the dominant cost in construction. Autonomous systems do not sleep, do not need benefits, and do not get injured on site. Over time, if the technology matures, it could dramatically reduce the cost of building large infrastructure. And think about the developing world. Billions of people lack reliable access to electricity, clean water, and modern infrastructure. If autonomous construction makes building dramatically cheaper and faster, it could accelerate development in parts of the world that desperately need it. Critically, China is not just building this for domestic use. Through the Belt and Road Initiative, China has been building infrastructure across Africa, Southeast Asia, and Central Asia. Autonomous construction technology could become a major tool of Chinese geopolitical influence going forward. The critics and the concerns. Of course, not everyone sees this as purely good news. Environmental concerns are real. The upper Yellow River Basin contains fragile ecosystems and is home to endangered species. Each dam in the cascade alters the river's flow, sediment transport, and ecological balance. Environmental groups have raised concerns about cumulative impacts on the river system. Concerns that do not disappear just because the construction method is more technically impressive. Labor displacement is another issue. If autonomous construction systems scale globally, they will displace construction workers. This is a sector that employs hundreds of millions of people worldwide, particularly in developing economies. The productivity gains go to whoever owns the technology. The workers bear the cost. There is also a geopolitical dimension. China is currently ahead of most of the world in this technology. If autonomous construction becomes foundational to global infrastructure over the next few decades, and China controls the leading systems, that is a significant strategic advantage, and a concern for Western governments already worried about technological dependency. And then there is the fundamental question of dam safety. Dams are safety-critical infrastructure. A dam failure does not just destroy property, it can kill thousands of people. The question of whether AI-controlled autonomous construction can consistently meet the safety standards required for large dams is still being answered. Yangqu is, in some sense, the proof of concept. The world will be watching very carefully. What comes next? China has announced plans to use similar autonomous construction technology on several other upcoming projects, including dams, tunnels, and railway infrastructure in difficult terrain. Other countries are watching closely. The U.S. Army Corps of Engineers, the European Commission, and major construction firms like Bechtel and Vinci have all been studying autonomous construction methods. But translating a promising technology from a state-directed Chinese mega-project into a commercially viable global industry is a very different challenge. The honest answer is that we do not know yet how far this technology will scale or how fast. What we do know is that the Yangqu Dam exists. It was built the way China says it was built, and it is generating electricity right now. That is no longer a concept. That is a reality. And reality has a way of forcing the rest of the world to catch up. The Yangqu Dam is one of those stories that sounds like science fiction until you realize it already happened. 3D printed infrastructure. Autonomous machines building a 60-story concrete structure in the mountains of China. Artificial intelligence systems making real-time construction decisions. A handful of humans watching screens while an army of robots does the work. This is where construction is going. The question is who gets there first and who gets left behind. If you found this video interesting, hit subscribe. We cover the big stories in technology, infrastructure, and the forces reshaping the modern world. And let me know in the comments, do you think autonomous construction is a breakthrough we should be excited about or a technology we should be worried about? See you in the next one.